Hello class, welcome back to week 13, and we are going to learn all about magnets. But first, let's go over our homework. Alright, here we go. This was our quizzes. And question number 1 says, what is the unit of force? Is it A, Newton, B, Nene, C, Nick, or D, nice? That's right, the answer is A. Newton is the unit of force. Do we need newtons to move? What do you think, yes or no? Yes. Without any force, we can't move. Does every force have newtons? That's right, yes. Every force has newtons. Does Newton have a newtons? Does Newton have newtons? Sorry, that's incorrect. Does Newton have newtons if he is standing still? Yes, because gravity is always on newtons, and gravity is a force. B, yes, because Newton never stands still. Well, this is if he is standing still, so that's wrong. And C, no, because Newton isn't moving. But even if he's not moving, there is still gravity. So the answer is A. So from the video, how did Mr. Bunny use push force? By running away. What is a non-contact force? No touching? Pick two answers. Wind blowing? No, because the wind is touching you. Kicking a ball? No, because you are kicking the ball with your foot. The electromagnetic force and Earth pulling the moon. Number 7, how do magnets pull? With the opposite poles. How do they push? With the same poles. What magnets do you think a bullet train uses to move very fast? Opposite poles or the same poles? Repulsion. It is repulsion. What material is attracted by magnets? Well, actually, it's probably both A and B, but maybe we'll learn more. What material is attracted by magnets? Some metals. It's not all metals. It's not plastic. It's not ceramic. And it's not glass. But some metals are attracted. Okay? Now let's begin. We'll learn more about that later. But first, let's watch a quick video. So everyone, let's watch.
This is magnetic, non-magnetic. I went around my house and I found a bunch of objects and I want to test it out to see if they're magnetic or non-magnetic, which means they're going to either be attracted by this magnet, which I got from our refrigerator, or not. So they'll either stick or they won't stick. And on this paper I have here non-magnetic and I have here written magnetic. And depending on the object, I will put them in this pile or this pile. Alright, let's start. I have here a cube. I'm going to see if it's magnetic or non-magnetic. It does not stick, so it will go here. I have a clip. Let's see what happens. It's stuck. It is magnetic. Put it right there.
That was a cork you would find in a wine bottle. That's a keychain. The keychain is magnetic. What's that? Ah, that looks like metal, but it wasn't magnetic. That metal was magnetic. And that metal is magnetic too. And that plastic thing isn't magnetic either. Okay. And last one, there's a, yep, the cover to a
I did it.
pot.
I sorted them all by either magnetic or not.
All right. So let's take a look at the book. What does the book have to say about that? So the book says magnets are objects that attract some metals, like from the question here. Some metals, not all metals. Okay? And magnets are grouped into two types as natural magnets, magnetite, and artificial magnets. So let's take a quick look. Now, let's answer question 1. That means we need to pause, okay? For question 1, we put an X over objects that can stick to a magnet, okay? Cross X over the objects that can stick to a magnet, okay? Pause now. All right, let's do it. So what can stick to a magnet? Metal, pin, or a clip, scissors, and a screwdriver. So it says cross X over the objects that can stick. All right. We don't need to answer this question. It's a bit hard, okay? If you did, it's okay too. Now let's read the next part. Uses of magnets. Wait, let's watch another video first. So let's take a look at this. Because we said some metals and not all metals, so let's take a look at how that works. Are all metals attracted? Let's find out. Iron, yes. Aluminum, no. Magnesium, no. Titanium, no. Oops. Cobalt, yes. Zinc, yes. Lead, no. Copper, no. Nickel, yes. Gold, no. Silver, no. Platinum, no. So we have nickel, cobalt, and iron that were attracted. All right. So what does that mean? Because those other metals weren't attracted to magnets, that they aren't magnetic, or they can't have an electric charge? Well, that's not exactly true. It just means that they aren't strong electric charge. But if you use a really, really strong magnet, it's a little bit different. Take a look. So let's take a look at copper again. So this one right here was copper, right? And nothing happens with a weak magnet in copper. So let's take a look at a strong magnet in copper.
Property of copper, nothing to do with electricity.
Let's take a look at a cool one.
Once again, is generated a magnet above the surface.
There we go. That one's pretty cool. So they're dropping this magnet.
The electrons are still flowing and cause very heavy resistance to a strong magnet.
On the copper.
We can do some interesting things like manually levitate a magnet.
What happened there?
Above the surface. I'm doing this by holding a second magnet underneath the plate. It's not easy to make a magnet float in this way, but it is fun to practice. I found that using a very
Okay.
wide magnet on top and a smaller magnet underneath is the most controllable setup. I made a small stand to hold my
All right, let's take a look at another
with
one.
the copper quickly without any surface-to-surface friction that causes damage.
So see, when we use a strong magnet, even this copper can pull or push the magnet.
In conventional braking systems between brake pads and rotors. My favorite tabletop demonstration of magnetic braking is to swing a magnet toward a chunk of copper like a wrecking ball. The magnet loses all of its momentum at the very last moment in a way that almost looks supernatural. It reminds me of a scene in the second Matrix movie where Neo stops
See how cool that looks?
bullets in midair.
That is
This
because of
thing is almost the
magnetism.
same thing that has happened in my other examples. The magnet's momentum is slowed by opposing magnetic fields generated by the flow of electrons.
So it's all about electricity and magnets. So let's take a look at the next page. Uses of magnets. How can we use magnets in our life? So magnets can attract or repel themselves. So, like we said, attract or repulse or repel. Also, they can attract magnetic materials, like the metals that we learned about. We can apply this knowledge in making useful objects for everyday tools. So let's take a look at this one. Make a check mark on the pictures that use magnets. Okay, so everyone pause now and do it. All right, let's check to see if you got it right. Compasses use magnets. Does a hammer? No, that just uses muscles. The refrigerator door? Yeah, that one does. The screwdriver? It can actually, because sometimes you can see that the tip of the screwdriver sticks to the metal. The magnet? Yeah, this part actually attracts staples. So yes. And a gavel? No. The gavel does not. It's just made of wood. So, we don't have to do this, but I will answer the question for you. And let's talk about the compass. How does it use magnets? Well, how the compass works, the compass always points north if it uses a magnet. So they put a magnet inside, and then the metal will always point north. The metal arrow will always point north. Okay, so that's how the compass works. All right, next. We have one more video at the end, but let's take a look at this last page. So these are some of the things where we can find magnetic materials and magnets. Let's take a look. So what can stick to magnets? Hair clips, scissors, 1-baht coins, pins. Other objects do not stick to magnets, do not stick. Like plastic straws, pens. Well, maybe a metal pen can stick. Erasers, which is rubber, can't. So let's take a look. The refrigerator we went around, this part of the fridge on the door can stick. And what about the front of the door? The front of the door is made of metal, and you can put refrigerator magnets on it. Okay. And what about this thing? Well, that's a door stopper, and it can keep the door open. So if you open the door all the way, it can hold the door in place, right? So the door can stay open even if it's blown by wind. Okay. Next is the mobile phone. Magnets are used in phones to make them work well. Well, that's true, because inside of the phone, there's a lot of different parts, like hard drives that store all of your pictures and videos. Those all need magnets. And what about the screwdriver? The tip of the screwdrivers are made with magnets, so they can stick to small screws and they don't fall off. It makes it easier. Let's take a quick look at some other things.
Uses of magnets. We use a compass to find out directions. The compass uses a magnetic needle to point north. Magnets are present in computers. Magnets present on a hard disk helps to store data. Magnets are used inside televisions, sound speakers, and radios. Magnets are used in MRI machines, which are used to create an image of the bone structure, organs, and tissues. The refrigerator doors stay closed because of magnets in the door frames. Magnetically levitated trains, known as maglev trains, use magnets under them to float above the magnetic tracks because the magnets are repelling each other. Magnets are used in ATM cards. The dark strip on the back of ATM cards is of magnetic nature and are used to store data. Magnets in vending machines are used to separate and sort coins. Vending machines check the money to ensure money is genuine. Magnets are used to separate the things made of iron or steel from other items. At home, we use magnets to stick papers on the refrigerator in order to remember something. Magnets are used in food processing industries for separating small metallic pieces from grains. Question time.
All right, good. So your question time will be on the quizzes. So we're going to have a magnets quizzes and talk about what materials or what things have magnets and what don't. And we're also going to talk about what metals are easy for magnets and what metals need very strong magnets. That's all for today's class. Good job, and I will see you next class. Bye.